Koenigsegg Gemera, a new Koenigsegg with a new powertrain layout again. As Christian himself has already explained it superbly, I won't do the same again. In this video, we'll talk about something which is very weird, but no one has talked a word about. The propeller shaft and the torque converter arrangement, where the torque converter is mounted after propeller shaft, which is very unusual. Let me clear it for you. It's not for weight distribution or packaging reasons. It's a lot more interesting than that. So, let's untangle the real reasons for weirdly placed propeller shaft and torque converter of the Koenigsegg Gemera. Let's see the power flow from the engine. The power from the engine is combined with crank-mounted electric motor, which then goes to propeller shaft, which further goes to torque converter, then to hydraulic clutches for torque vectoring, and then to the wheels. Generally in automatic cars, the torque converter is mounted directly after the engine. Then there's transmission, then propeller shaft. In case of Gemera, the torque converter is after propeller shaft, with no transmission as regular. Here's the technical explanation for such placing. If you have ever designed a propeller shaft or any other transmission shaft, you may know that no matter how much power you have to transmit or at what speed, the only thing which matters is the torque to be transmitted. More the torque to be transmitted, more the required strength of material, shaft diameter, thickness of the shaft in case of hollow shaft is. Power is dependent upon two components, RPM and torque. So to transmit any power via shaft, it's wise to do it on high RPM and low torque to make the propeller shaft lighter and smaller. If the power is transmitted at high torque and low RPM, then bigger and ultimately heavier shaft is required. There's no way for the second option in a car like Gemera, as it needs to be lighter as well as it should have a thinner tunnel to fit 4 passengers in the cabin comfortably with sufficient room. Talking about the size of the tunnel, the diameter of the shaft is very crucial factor, as the tunnel has to accommodate the shaft as well as the support which fits the size of the shaft. You can say bearings for the shaft for supporting it to prevent it from bending, whirling. These supports require additional space. So a smaller diameter shaft is always better in such conditions. The torque converter has 3 stages. One is open up, when there is no power transmission, 100% slip. Then there is torque multiplication mode, where the torque converter can nearly double the torque. And the third mode is lockup, that is 1:1 speed and torque transmission ratio. If the torque converter was fitted before propeller shaft, then in case of torque multiplication mode, the output torque will be almost twice. So a bigger and heavier shaft will be required, decreasing the cabin space as well as the performance to some extent. With the current setup, the propeller shaft was needed to be designed just to transmit 1100 Nm combined engine and electric motor, and not almost twice 2200 Nm. Now a clever question. If less torque requires smaller, lighter propeller shaft, so why not fit the crank-mounted motor after propeller shaft? That way you just need to transmit 600 Nm of engine torque. Well, it's not that simple. Here's why. Let's say the electric motor is after the propeller shaft. Then in case of cranking, as the electric motor is supply side and the engine is load, means resisting side. So while cranking, when the electric motor will put power towards the engine, the propeller shaft will twist in this direction. Then once the engine starts producing power, it will no more act as load. Rather, it will start transmitting power towards the wheel to support the electric motor. In this case, once the engine starts producing power, it will twist the propeller shaft other way. That's an instantaneous change in direction of twist. The Gemera also has just 3 cylinders, so the torque and speed output for each revolution isn't very continuous. To add up to that, at every acceleration and deceleration, ever slow slight non-synchronization of speed between engine and electric motor, the twist direction can instantly change. In such condition of oscillating change in direction of twist can lead to premature failure of propeller shaft. So, the electric motor is not mounted after propeller shaft, and such positioning of propeller shaft and torque converter is done. Something different, something interesting. If you like this video, make sure you hit the like button and subscribe to our channel if you haven't yet. Also make sure to hit the notification bell for future updates. Do share this video. Thank you for watching.